Hello, in this video we are going to look at work energy theorem. The work done on an object by net force is equal to the change in the object's kinetic energy. Now let's see how this formula is applied in solving question. A box with a mass of 12 kg accelerates from rest from A to B over a horizontal surface when a force of 300 Newton is applied parallel to the surface AB. The applied force is removed as the block moves from B to C down the inclined plane, making an angle of 30 degrees with the horizontal. The constant frictional force acting on the block between A and B is 3 Newton, and the constant frictional force acting on the block between B and C is 1 Newton. AB is equal to 12 meters and BC is equal to 20 meters. Now, before you start solving the questions, the informations that you have to try as much as possible to label all the information on the diagram if it is not given on the diagram. So now, from the question, we can see that the angle that the incline make with the horizontal is 30 degrees. So we can therefore put our 30 degrees angle there. And the distance between AB is giving us 12 meters. And then BC is giving us 20 meters. And the friction between AB is giving us 3 newtons. So the friction at this point is 3 newtons. And the friction between BC is 1 newton. It's equal to 1 newton. Now therefore, you see, you may only use work energy principle to answer this question. Calculate the speed of the objects at point B. Now, to calculate the speed of the object at point B, the object starts at point A from rest. And when an object starts from rest, its initial speed is going to be 0. So we have to use the energy principle, and the energy principle we can use here is the work energy principle. Is one of the principles that we can use. So in this question we are going to use the work energy theorem, and the work energy theorem states that the net work done on an object is equal to the object's change in kinetic energy. So if we have the net work done on an object equal to the object's change in the kinetic energy. So at this point, we should find all the forces acting on the object and figure out which of the forces does work on the objects. As the object is on this horizontal surface, we have the normal force, we have the gravitational force, we have the friction, and we have the applied force. And the direction of motion too is to the left. So we can see that the applied force and the direction of motion goes in the same direction. So that angle between them is going to be 0. And the friction and the direction of motion goes in the opposite direction, which is the angle of 180 degrees. And we can see that the direction of motion and the gravity or the normal force act as at 90 degrees. So that is going to be cos 90. So the normal force and the gravitational force does 0 work. So now we're going to expand the work nets. So we therefore say that the work net is going to be the work done by the applied force plus the work done by the friction plus the work done by the gravity plus the work done by the normal force is equal to, now change in the kinetic energy, which is the half mv squared final minus half mv squared initial. So, and the force, work done by a force, is equal to that force multiplied by the displacement multiplied by the cos of theta. So if I want to find the work done by the applied force, I need to take that applied force, which is mentioned as 300, multiplied by the displacement, which now in this case is 12, and multiply by the cos of the angle, as we have mentioned that the cos is going to be 0 because they go in the same direction. Now plus the work done by the friction. The friction is 3, and then the displacement is 12. Now multiply by the cos of 180 because the friction goes in the opposite direction. And for the gravity and the normal force, they are going to be 0, 0, which is equal to now half of my mass, which is 12, and my final V is what I am looking for, which is V squared, and then minus, now my initial here, my initial velocity is going to be 0. So if my initial velocity is going to be 0, that means if I put 0 in place of the V, it makes everything here to be 0. So now if I have to put everything from this point to this point inside my calculator, I am going to have 3, 5, 6, 4, which is equal to, now this part here would give me 6 V squared. So therefore I am going to divide both sides by 6 to have 594, which is equal to V squared. Then taking the square root on both sides, I am going to have my V to be equal to 24,37 meter per second. So that is going to be the speed of the object at point B. Now the second question is, calculate the speed of the object at point C. Now to calculate the speed of the object at point C, the speed of the object at point C, when the object reached point C. Now to do the free body diagram on point C, when the object reached at that point, point C, the applied force was removed. So now the forces acting on the object, we shall have the normal force and we shall have the gravitational force and we shall have the friction and the normal and the gravitational force. So the normal force and the direction of motions is also down. So the normal force and the direction of motion act at 90 degrees, so the normal force does a 0 work. So using the work energy principle, we shall also say 7.2. So we shall also say the work net is equal to the change in the kinetic energy. So now what are the forces? We are looking at work done by the gravity. So work done by the gravity plus work done by the friction plus work done by the normal is equal to now change in the kinetic energy, which is half mv squared final minus half mv squared initial. So now as the gravity goes down, as the object goes down the slope, now gravity always goes down, so the object is on the slope here, going down, and the gravity also goes down. So to find the angle between the direction of motion and the gravity, we are going to find it here. This is the direction of motion down the slope, and the gravity goes down. So the angle between the gravity and the direction of motion is this angle here. And to find that angle, we are therefore going to subtract 30 from 90, because this is sum of angles in a triangle. So 30 from 90 gave us 60. So therefore, our angle is going to be 60 degrees. So now therefore, to do our substitution here, work done by the gravity, we shall have work done by the gravity, we shall have the mass. The gravity is given by mass times the acceleration due to gravity constant. So the mass of the object is 12. So we shall have the 12 times 9,8. And then multiply by the distance, which is 20. And then now multiply by the angle, which is cos 60. Okay, multiply by the angle, which is cos 60. So now plus our friction. Our friction is 1. So we are going to take our 1, and then we're going to multiply 1 by the distance, which is 20, multiply by cos. Friction goes in the opposite direction, which is cos of 180. Friction always does the negative work done. And then we shall have our normal force, which is equal to 0. So now we're going to now equate this to changing the kinetic energy. So we have half of the 6, half of the 12, the mass is 12. And then the V, which we are looking for. And then minus the half of 12 again. And then our initial velocity at that point was 20. It was 24,37. And then squared. So if we have to put this from here to up until this point inside our calculator, our answer is therefore going to be 1156 equal to, now this half of 12 is 6, so 6v squared. And then at this point, the whole of this will give us 35. 63,3814. So now therefore we have to transpose this to the other side, and then we shall have 4719,3814, which is equal to 6 squared. So now all we have to do is to divide by 6 on both sides and take the square root of our answer to get our V, which is equal to 28,5 rounded to 2 decimal place meter per seconds.